Algebra 2 Honors, Lesson 6.1, Graphing Quadratic Functions. So we talk about quadratics, which are important because anytime you throw an object into the air like a rock or something, it'll travel in a parabolic arc. So if you're ever thinking of studying physics, there's going to be a ton of parabolic information. There's parabolic cones that are used to collect satellite rays to power your cable TV and things like that. Not power, but to be used for cable TV. So this is why it's important. And this is the general form. ax squared plus bx plus c, where a never equals 0. So to graph them, you find the axis of symmetry. And to do that, you put in negative b over 2a, which in this case is negative 8 over 2 times 2 gives you 8 over 4 equals 2. So that's your axis of symmetry, and as you can see in this parabola above, axis of symmetry means that the sides are equivalent on either side of the axis of symmetry. I'm going to force you guys to make graphs just because it's a good skill to develop. And then graph paper is not a bad idea when you're doing lots of quadratic problems. Take that, plug it back in. It's going to tell you where the vertex is. Multiply that out, you should get 1. So we go over here and we plot 2, 1. I forgot, I meant to do my axis of symmetry, which is x equals 2, so it's a vertical line at 2. And then we find the y-intercept, which is just what we get when we put in 0 for x. Hopefully you realize anything with an x in it's going to zero out, and you're just going to be left with the c value. So you don't even need to do this. Just say it's 9. It's always going to be c value. So up here, and you make a little parabola. Goes up, and you make a carbon copy on the other side. There are teachers who will make you do this. And since we're at 2, let's try 1 and 3, and maybe 0 and 4. Plug these into the equation. We get 3, I believe. Here we'd get also 3, I believe, which makes sense. So 1, 2, 3, right about there. And on the other side, 0 we already know gets us 9. 4 would also get us 9. That sort of thing. I won't make you do that, but some teachers might. Let's label this sucker. This is our axis of symmetry. This is our y-intercept. This is our vertex. And it's 2, 1. And one of the questions I have below is, what are the x-intercepts? There are none in this case. X-intercepts would be where they hit the x-axis. As you can see, there are no spots where they hit. So all of these questions are answered in the top problem. Now it says here, graph again without a table. It's pretty much what we just did. Notice a nasty little trick here of putting it in the wrong order. Also notice that we have a y instead of an f of x. They are interchangeable. A lot of students get hung up on that. It doesn't really mean anything. It's just notation. So x equals negative 9 over 2 times 1 equals negative 4.5. So we go over to 4.5. Plug that in. I'm going to use negative 9 halves just because I can do that math a little bit better in my head. And we get 81 fourths plus 81 halves, negative 81 halves, which is negative 161 fourths, plus 8. Pulling out a calculator here, so we get negative 81 plus 32 fourths. Seems a little bit on the high side. We get negative 49 fourths, which is negative 12.25. So it's down here somewhere. This is our vertex. Negative 4.5, negative 12.25. And then it comes up and hits somewhere, and we really can't tell where till next lesson, where we'll show you how to do it on a calculator. But I happen to know it's going to hit about here and about here. And we nearly forgot, I nearly forgot, y-intercept 8. Right about there. So axis of symmetry. For now, we'll just indicate. We're not going to actually label them. X-intercepts, vertex, that's everything. So this graph have a maximum or a minimum? It has a minimum. We know that because the A value is positive. We'll have a U. If the A value is negative, we have an upside down U. So you'll see examples of that coming to a videos in your near future. That's it. Good luck.